Hello and welcome to our demonstration of DeepEye Beta. So today I'd like to guide you through the software that we've developed in order to grade retinal scans of diabetic patients. So the first thing we do is download a dataset consisting of 40,000 images, which have all been labeled by an expert ophthalmologist. Of these, we took 1,000 images in order to train our convolutional neural network, which forms the crux of our machine learning platform. So this is an example of a couple of the images that we use. So as you can tell, all of these images are varying in size and also in other forms of spatial characteristics. So we need to normalize them in order not to upset the training process of the convolutional neural network. And so we wrote a normalization script which prepares the datasets for us. Now I'm not going to run this explicitly, but I'm going to show you exactly what we do. So firstly, we resize the images such that they're all exactly the same size. So in this case, I've sized them at 250 by 250. So these images are typically around 2500 by 2500. And the reason why I've chosen this small aspect ratio is to reduce the load on the GPU that we have in order to reduce the training time for this demonstration. So this is where it all happens. This is our convolutional neural network. This is written in a programming language called Python. And this is written using a toolbox called Theano, which is a very powerful machine learning toolbox that represents the gold standard these days in writing machine learning code. We wrote our own implementation of the convolutional neural network, and we selected an architecture that we could optimize such that we get the best classification results and minimize the error. So I'll quickly go through how our deep neural network learns to classify diseased eyes from non-diseased eyes. So we used the 1,000 images I just showed you to train this network, and we selected 30 of these images as a test. In this test, the objective is, given these ground truths that have been generated for us by an expert ophthalmologist, where 0 represents no disease and 1 represents a disease, we'd like the convolutional neural network to reproduce these results as accurately as possible with only the images being given to it. The convolutional neural network learns the underlying features and representations and distinguishes the diseased eyes from non-diseased eyes. So I'm going to train the convolutional neural network. The first thing I do is I bring up my convolutional neural network by running it in Python. And all of the hyperparameters have already been selected. All of the parts of the images have already been specified in the Python script. And so I just run it. It takes quite a while to load, to run. So here it's just loading up the GPU. So I'll get back to you afterwards, had a couple of epochs, and just guide you through exactly what's going on. So we're halfway through the number of epochs that this convolutional neural network is taking to train. And what's happening is that we're passing the 1,000 images through it, and it's learning the key underlying features and representations that distinguish the disease from the non-disease. And we've automatically included the test files in the end of the script such that I can classify them. So here you can see it's classified the 30 test files, and it's also saved them to our desktop. So we can just quickly open that to see how it's performed. So we'll just include the spacings. And yeah, so I'll just quickly copy this into the pathologist grading to see a comparison. Fantastic. As you can see, it's performed incredibly well. It's predicted with 100% accuracy all of the disease samples. It has predicted with 100% accuracy all of the normal samples, and just from that small amount of training that you saw. So what's the next couple of steps that we plan to take? So disease versus non-disease is useful, but to make it clinically useful, we need to provide the ophthalmologist grading, which is between 0 to 4, where 0 represents normal eyes and 4 represents the more aggressive forms of the disease. So the way we'll achieve this is investing more time into optimizing our code, investing more time into much more tuned hyperparameters in the convolutional neural network, and also investing in the technological aspect. So for example, having a much more faster GPU with more RAM in it so we can load larger images. And large images correspond to a bigger feature space, so that should be able to allow us to distinguish more of the features that will allow us to distinguish between the 0 to 4 gradings. We also plan to export our software to smartphones, to iClouds, anywhere where you can write a wrapper, to be honest, because we believe that this software can be utilized by many people, and especially people with smartphones and stuff. So thank you for your time, and we hope you've enjoyed our demonstration of DeepEye beta.